To our Fredericton Amateur Radio Club meeting tonight, we welcome this presentation, SDR Applications for Your Shack, New Applications for Low-Cost SDRs. Welcome, Ted WR4T Tango.
Well, thank you, Brent. Appreciate you having me come and talk to the club tonight. I suspect that this presentation will end up looking a little bit like a show and tell, but this all started when I sent Jerry a Skype and I said, "Hey Jerry, I've been working on something with this inexpensive SDR I got up at Dayton this past year, and I was wondering if you could do some testing with me." And he's like, "Oh well, you should do a presentation on your project." after we talked about it for a while. So in any event, you know, SDRs have been with us for a while, but they keep getting better, a lot of new capabilities, and the costs, the costs either come down on the high end, they're coming down on the low end. The functionality and capabilities is ever increasing. So when I was up at Dayton this year, I picked up one of these low-cost SDRs. A couple of reasons it was attractive to me. First of all, I'm going to hold it up in the camera if you guys can see my camera. This one is from a company called SDR Play, and there's lots of different companies making these low-cost devices. The thing that I liked about this particular model is that it had very good low-frequency performance, down into the audio range, 1 kilohertz, and my high-end $30,000 Spectrum analyzer only goes down to 9 kilohertz. And I needed something that did a little bit better job in the audio spectrum. So that's it's for a phase noise measurement test setup I have. But anyway, once I got it, I started looking around at a lot of different capabilities, and there's all different ways you can use these in your shack. And I was just going to show a few things along that line today. So first off, I just wanted to give a overview of SDRs, and how the technology is evolving and what's changing, and the primary SDR architectures and what some of the differences are in the architectures. So at the top of this diagram here, you see what looks like a traditional super het receiver. This is a dual conversion super het receiver with RF filtering in the front end. This block diagram only has one section of IF filtering. After your first IF, this is typically where your roofing filter is in a more modern radio. And then your second conversion into your second IF. And in a traditional radio, this would be where you'll have a lot of additional crystal filters, and then your product detector. Of course, this will all be wrapped up in an AGC loop. But around, in the late 90s, early 2000s, you started to see radios that popped up with digital signal processing in them. And digital signal processing is a form of a software-defined radio. It just implements really the last IF stage, the detector and filtering. And the big benefit you saw in those radios was that you were no longer limited to 2 or 3 filters you had plugged into the radio. The filters were getting quite expensive. They're well over $100, sometimes approaching $200 for a good crystal filter now. And if you get a high-end radio that has 9 crystal filters in it, you could easily end up with $1,500 of crystal filters in a radio, and that's why some of those high-end radios now are $6,000 and above. But so by doing that last function with a low frequency IF, typically this second IF was like 50 kilohertz almost like back in the 1930s and 40s with the low IFs and radios back then. And they would implement an analog to digital converter, and then they would do the detection, the product detector, and the filtering, all at low frequencies. And these were typically the analog devices, DSP chips. They're shark Shark family, Blackfin, or the Texas Instruments, TMS digital signal processors. They were really designed for audio frequency, maybe up to a couple hundred kilohertz. Then what happened, and really the main limiting function at that time was the cost and speed of the analog to digital converter. Well, analog to digital converters kept getting faster, costs came down as silicon processes continued to scale down. And I think it was, maybe around 2005, give or take 2 years. I can't remember exactly when. In QST, there was a series of articles published called, SDR for the masses. And it was a really nice article, and there was a homebrew SDR in there, which actually became the basis of the Flex SDR 1000, their first SDR. It was essentially the same radio, and there were a few clones, like the soft rock radios. Are based on a very similar architecture with this TALO detector. But anyway, it's a direct conversion receiver. So what it does is you have a mixer, and generally it's just a single conversion. You have a local oscillator mixer, and it goes all the way down to a very low frequency, down to DC. So so the audio band, and with the A to Ds available at the time, they were using sound cards. The computer sound card ended up being a pretty inexpensive analog to digital converter, and typically you could get those computer sound cards. Some of them would sample all the way up to 192 kilosamples per second. 48 and 96 kilosamples per second were very, very common. Some of the high-end cards, the Sound Blasters and a few others, could go all the way up to 192 kilosamples per second, and 16-bit samples. And so this digital signal processing could all be done on your computer, because all the computers at that time had floating point coprocessors in them. And that's when, I would say Power SDR was the open source software that Flex came out with. And that software is used today. And that was the next generation. And this direct conversion concept is primarily what's used in all of these low-cost SDR receivers you can buy on the market. The SDR plays use this direct conversion, many others. There are some direct sampling that are coming along, and that's this architecture along the bottom. So the direct sampling, the big difference here is that your analog to digital converter now is connected directly to your antenna. So you come in on your antenna, you have a low noise amplifier here, you have some bandpass filtering, your traditional LC filters. Sometimes they're just a bank of half-octave filters. Sometimes they're more elaborate bandpass filters around the ham bands and the higher performance radios. And then you go straight to your analog to digital converter, and your analog to digital converter is sampling. It samples the signal, and it samples it again in 90 degrees, shifted in phase 90 degrees. So you have to sample it with a 90 degrees offset to get the phase information of the signal as well as its amplitude. So in order to do digital signal processing, you need to have both the amplitude and phase of the signal you're receiving. Conventional radios generally only deal with the amplitude. They throw away the phase information. But in digital signal processing, the phase becomes critical. But so these analog to digital converters generally now are either 128 megasamples per second or 256 megasamples per second. Either 14-bit, like an ICOM 7300 is a direct sampling radio, has a 14-bit A to D that gives you about 90 dB of dynamic range, which is pretty good. The 16-bit samplers will get you closer to 96 dB of dynamic range. And again, that's very good dynamic range. It's not the equivalent of what you can do with a high-end analog radio. You can, even the inexpensive analog radios will be 110 dB, maybe 113. You can get into the very high-end radios, and they'll be, approaching 120 dB. And of course, there's different ways to measure dynamic range. Blocking dynamic range, 130 dB if you're just measuring blocking dynamic range, which, so you lose dynamic range with a digital, with a DSP-based radio, but that really is only going to affect you when you're operating your radio very close to a high-power transmitter without filtering. If you have filtering, if it's another band, it doesn't bother you because you have good bandpass filters. So someone can be operating next to you on 20 meters. The good direct conversion radios have very good filters in them. It's not going to bother you. It's only when they're in the same band. And just to give you an example of Elecraft, they just released their first direct sampling radio, the K4, and in order for it to equal the specifications of their older K3, they actually have an analog receiver board as an option you can add to the radio, and it will operate with both the direct sampling receivers and the analog receiver. And of course, the transmit's always digital in either case. So one thing I want to note about these direct sampling, I said direct conversion, I meant to put direct sampling. There's a typo here in my presentation. But the direct sampling receivers really first came into amateur radio through TAPR. I don't know if people remember the Tucson Amateur Packet Radio Club or Association. They brought us packet radio and TNCs. They developed an open source platform for that. Well, they developed an open source high performance. They called it their high performance SDR project. And the very last thing they developed was a single board radio. They used to have it all it was like 6 or 8 cards, and they all plugged into a chassis, and they had a card for the filters and all that. And a lot of people, a lot of enthusiasts built them, but then they shrunk it all down to a single board, and they called that board the Hermes. And you can look around for the Hermes board. There's TAPR doesn't make that board anymore. I think they only spun it once, and they sold it out. But then other people started making them, and the Anon radios are TAPR clones. So those radios were not designed by Anon. The software wasn't really developed by Anon. They're really just making an open source radio and using software and hardware that was designed and developed by others. They took that and built a full featured radio around it, packaged it very nicely, put in a very high performance power amplifier, added the pure signal capability. They did some nice enhancements with that, and it's made that radio very, very popular, and it's a good radio. So, as I noted earlier, there's just been a real proliferation of these low-cost SDRs, and they start even lower than $50. These $50 ones are 8-bit USB dongles. They typically don't have any filtering in them. They're very easily overloaded. But if you control the RF levels in them, and they are quite usable, but they have a lot of limitations. And you can get up to, I would consider maybe up to $300. You can get a really high performing one with lots of filtering and lots of capabilities that will perform. When you get up into the $300 range, you're probably getting an SDR as a receiver that's going to perform as well as almost any HF rig in most cases. And some things the SDRs do better, something the analog radios do better. Like I said, the analog radios have better dynamic range. The SDRs generally do a much better job with, interference mitigation, the noise blankers, the AGC, I think is better in an SDR. The filtering is typically, in most cases, is better. There are some advantages to analog filters, but for most day-to-day operations, the filters I think are significantly better in the SDRs, less ringing, easier to adjust. I run CW a lot, and sometimes 150 hertz filter it rings a little bit, and if you get one that's a crystal filter, they ring a lot. But I can easily tailor the filter to maybe 200 hertz if I don't, or 175 hertz. I can control it and get the exactly sweet spot between bandwidth and ringing and that I need under certain band conditions. And you just can't do that with an analog radio. So as I mentioned before, these low-cost SDRs are generally not direct sampling. There are a couple on the market that are starting to appear that are direct sampling, but most of them, they down convert to from DC to a couple hundred kilohertz, maybe even all the way up to 10 megahertz, and then they sample that down converted spectrum. So it's essentially a direct conversion receiver with a analog to digital converter attached to it to do your filtering and detection. And as I noted before, the down converted spectrum could be from 0 to a couple hundred kilohertz all the way up to 10 megahertz on the SDR plays. And so here's some of these common SDR, low-cost SDR. So Kiwi SDR, by the way, that is a direct sampling radio. It is not direct conversion. It's direct sampling. So the SDR plays, AirSpy, New Electric, Hack RF, ELAD, Soft Rock, Win Radio, Red Patai. I built a Soft Rock, had a lot of fun with it. The Soft Rocks generally work with Power SDR, and they transmit as well. Typically, they only cover a couple of bands, but that was a fun radio to play around with. And today, I just wanted to talk to you about some of the things I've been able to do with the SDR Play. So just to let you know, the SDR Play SDRs, they start at $120. I think the model, Brent, this is U.S. dollars, by the way, not Canadian. Brent, I think the model you have is was like $120.
Yeah.
Their high-end radio has dual analog to digital converter. So I'll go through them real quick. Their entry levels, the RSP-1A, it's a single analog to digital converter, a single signal path. It receives on one antenna at a time. I think it only has one antenna input. There's only one set of filters, and it has very good HF performance. The model I'm going to be talking about today is the RSP-DX. It has some additional filtering for the low frequency and VLF bands. It has an AM broadcast band stop band filter, so you can turn that on and it knocks the AM broadcast band out at least 50 dB. It's a pretty good filter. It has 3 antenna ports with a built-in antenna switch. Again, you're switching between one antenna at a time. That's something I want to really emphasize as you compare it. And this, on their website, this model, I think it was on their website for $215, and I got at the Hamfest, I got it for $75 off, because it was $25 off. They were running a special at, where did I buy it from? Ham Radio Outlet? I think it was Ham Radio Outlet. And then I went to the Ham Radio Outlet booth in Dayton, and SDR Play, the company reps from the UK were there in the booth, and they're like, oh, we have a $50 off promotion on top of that. So just for the Hamventions, that was a special ham. So it ended up being like I think it was list price was $225, and I ended up paying like $150 for it. So it was a $75 off. Then their high-end radios is RSP Duo. That's like a $300 radio. Now, this has dual analog to digital converters. It has dual signal paths. It processes from 2 antennas simultaneously, so that gives you true diversity receive capability. And you can, and with the phasing adjustment, if you have the right type of receive antennas, you can do an electronically steerable null in your pattern. You can adjust the phasing between the 2 signal paths. and null out interference in a specific direction and get quite steep null, which is something these dual A to D receivers are capable of. This capability has been around for a few years. It's still, the software is still getting better. They're still not perfect, and they require a little bit of I would say you kind of have to ride the controls to get the performance you want out of it. They're not as automatic as you'd like them to be just yet, but they are. That technology is improving all the time. So the next thing I'm going to do a demo of is your when you have an analog to digital converter there, you don't have to use it just as a an HF receiver. If you've ever used a spectrum analyzer, or particularly if you're familiar with spectrum analyzers from the old days, really a spectrum analyzer is nothing more than a sweeping receiver that will sweep through a range of frequencies with a very accurate, calibrated signal level display, and a set of very expensive, precise attenuators that give you very flat amplitude response, a very accurate log amplifier. When all this was done with analog electronics, a high-performance spectrum analyzer, even in the 70s, could cost $100,000. So, I don't think there's any spectrum analyzer on the market that approaches $100,000. There might be some that approach $100,000, but they were $100,000 in the 1970s. And that would be, well over $500,000 in today's dollars. And there's nothing that expensive on the market anymore. But with application software, your SDR can become a pretty high-performance spectrum analyzer. You will not have the precision attenuators you have in a spectrum analyzer for looking at high, strong signals, 30 dBm. You put a 30 dBm signal into your SDR play and it's going to smoke. So you got to be careful about that. 30 dBm is 1 watt, by the way. This particular SDR with the software will operate from 1 kilohertz up to 2 gigahertz, and even traditional spectrum analyzers, a lot of them will not do these audio frequencies with the same level of performance. So what I'm going to do here is I'm going to do a little bit of a demo. I don't have my SDR play connected to my server at the moment. Someone asked me about that. What I do have it doing is I have it hooked up to a signal generator on my bench. Right now I'm tuned to 1.3 gigahertz, 1300 megahertz. And, I've tuned into a pretty weak signal. I'm going to turn on averaging here to get the noise floor down a little bit. And it's improving a little bit. But, this particular application has functions like markers. So I can put a marker on here. Let me turn the markers on. Similar to what you have on a high performance. Let's see. Yep. I gotta get this on the right trace. There we go. Okay, so your markers read. This is a pretty weak signal. It's minus 101 dBm. And you can see the noise floor here is down in the minus 160 dBm range. That's a pretty low noise floor for an instrument in this cost level. This thing has a noise figure that's probably around 10 dB, maybe even a little bit less. Maybe it's more like 8 dB noise figure, which is typical of any high performance spectrum analyzer. So I was pretty surprised that the noise floor was this good. If I crank the signal up, what you will see here is that the phase noise on this, I'd have to show you. I'm not going to demo that now, but the phase noise is not as good as you would find on a high-end spectrum analyzer, but it's still very usable. So this is a free piece of application software you can download, and and you can export all the data to Excel. So if you want to do one thing this doesn't do, it just does a linear frequency display across the x-axis instead of a logarithmic one. Some applications I need to have a log frequency display, so I can export all the data points into Excel and do a nice, pretty log plot in Excel if I need that. So that's one application I wanted to share with everybody. So I'm going to close that out and talk about another application. Oh, okay. So one thing that, a lot of people like the SDR radios for, the new high-end radios like the ICOM, or, even the ICOM 7300, is the pretty pan adapter display. And I find the pan adapter to be extremely useful. It just, you can see what's going on in the band. I mean, I very rarely look at more than one band at a time, but I can see what's going on in the band very quickly. I can see if there's a CW contest going on or a phone contest, see where all the activity is. You can look at the, on the CW, you can see down in the DX window if there's any DX down there. You can even get connect to a DX cluster, and it will actually put a call sign on all the little different signals on the band. And if you want to work to that guy, you click on the call sign and it automatically tunes your radio. And that was something I loved about the Flex. Well, you can do that. You can incorporate these SDR radios and have them control your traditional transceiver and use it as a pan adapter. So I was just going to play a little demo. That this is just a snippet of the video from SDR Play's website. So hopefully this plays okay. If not, let me know and I'll try to explain what's going on. Otherwise, I'm just going to play this.
Here we see SDR Uno set up with a single VRX as a pan adapter controlling the Kenwood 590 SG. In its current mode, with the rig sync button depressed, anytime we change the tuning within SDR Uno, it will be reflected by the rig. So for example, if we move to this...
so this is the 590 display over here in the lower right corner.
We find that straight away the rig has followed us down to 14.0735. Conversely, if we change the tuning on the rig itself by moving the dial, we find that SDR Uno will follow us. So we have bidirectional sync between the rig and SDR Uno. But something else we can do is, if we pick up a signal that we're working on the rig, for example here, we can turn off the rig sync button, and that allows us in SDR Uno to go and look at what else may be going on. For example, this signal at 14.247, we can leave the rig where it is, and we can turn on the audio in SDR Uno, and so we can monitor what else is going on in the band without adjusting the rig itself. Obviously.
Okay. I'm going to stop that there. I don't need to go into any more of that. But that was just a quick demo. Now, in order to do this, just to give you a quick overview, there's two ways to do this. First of all, you have to have a serial or USB connection from your computer that you're running the software on to the radio you're controlling. So you have to have a radio that has an RS-232 and supports the, typically what are called CAT commands. Anyone who's ever hooked up a logging software or anything to their transceiver would be familiar with that. But I mean, you can go back as old as radios like the Kenwood TS440, which came out in maybe, I don't know, 1988, 89. The TS450, early 90s. Even radios as old as that. Now, the newer radios will make it very easy because you'll have a port on the back where you can make the antenna connection to feed your SDR. So I'll just quickly show what that looks like on the 590.
By a screen with the range from 14 to 14.35 megahertz. There are several ways to connect an antenna in a pan adapter configuration, but one nice feature that the 590 SG offers is the DRV output, which can be configured to be an antenna out, effectively providing a nice clean signal to the RSP without fear of it being overloaded when you press the transmit key. The DRV output can be used in two ways, either to drive an external amplifier or in our case as an antenna out jack. So you will have to go into the menu system.
Okay. What they're noting here is actually to enable this function on the 590, you have to go into the menus on the radio and configure that DRV RCA plug to be an antenna output. Now, if you do not have a radio that has this feature, and many of them won't, particularly when you get to the radios from the late 80s through 90s, MFJ sells a box for connecting your SDR, sharing the antenna between your SDR and your transceiver. And you can go to the MFJ website and search for that product, and it's pretty common. So that's another way you can add a pan adapter. Now I think the Fredericton Club has a 590 in their club station. If you don't have a pan adapter on it, this would be an option for putting a low-cost pan adapter on that radio. Now I'm going to go back to the presentation, and then we'll get into some of the other interesting applications. Okay, so this is what I primarily wanted to talk about, and one of the other reasons I was very interested in the SDR play. When I was at Dayton, they were showing their new software. Up until Dayton, they only supported the Windows platform with software, and they have an application called SDR Uno. And SDR Uno is still their primary piece of software. It has many, many more features than this new software that they just released called SDR Connect. But SDR Connect has some great capabilities in that it will run, same piece of software, will run on Windows, Mac, and Linux. And it operates identically. Everything about it is identical. You can't really tell whether it's running on Windows, Mac, or Linux. In addition to that, it's client-server based. So you can have it running on one machine in server mode and log into it on a client with a completely different operating system. So I can be using a Linux machine, like a Raspberry Pi as my server, and then I can connect to it on my Windows machine. And that's something we'll demonstrate here momentarily. So in order to do this, you need your SDR hardware. There's other SDRs that can do this, but the Kiwi SDR was one of those that operates in client server mode. But I'm pretty impressed with how easy the SDR Play unit was to set up and how easy it was to use their software. So you need SDR software that supports this client-server architecture. Then you need a computer to operate as a server. It can be a regular PC. It can be a PC running Windows, a PC running Linux, or a Mac. A Mac would be a very expensive piece of hardware to throw at this problem. There are some inexpensive single-board computer PCs coming on the market. Most of the ones I've seen are still well over $100, maybe $200. They're nice. I think that a lot of times they're called NUCs, NUCs. I can't remember what NUC stands for, but they're very low cost, small PCs. But the fact that the SDR Play software runs on Linux, offers you many advantages in that you can get very low cost hardware that supports Linux. And Raspberry Pi is one option. But once you do that, you can implement. And here, this is just a diagram of here's a Raspberry Pi Model 400, which is a Raspberry Pi embedded inside of a keyboard, all packaged, and I think it's like $99 with the keyboard. It's kind of a nice package they come up with, and power supply. Your SDR Play RSP, whether it be a 1A or a 1B or a RSP DX like I use. Then you can connect to this, in your house on your local LAN without doing anything special. You can also turn on port forwarding in your router to expose your server to the internet. Of course, there's some security risk when you expose a server to the internet, but so you want to be careful. I am still in the middle of configuring my wireless router so that my Raspberry Pi is not connected to this local LAN. It's on something called a DMZ. Some routers support that. I did notice that as soon as I turned on and opened up this port, I saw random IP addresses connecting to the Raspberry Pi, and I'm assuming they were trying to find out if they could SSH into it or connect to it in some fashion. But once you open a port to the internet, then you can connect to this anywhere in the world, essentially. And so what I have on my setup is I'm using a Raspberry Pi 4, this exact board. You can buy them with 1 gig of RAM up to 8 gig. The 1 gig RAM is $35 US. The 2 gig is the most popular option. I believe the SDR software will run fine on 2 gig, maybe even 1 gig. But when I bought mine, I got the 4 gig because I wanted to be able to do some other things with it. It was a $45 purchase. So my intent here was eventually to put this receiver out at our farm. We've got a family farm that's about 15 minutes from where I live here. I'm in a suburban area. Our towers, and local zoning restricts our towers to 35 feet, and they've granted some variances for some hams to go up to 55 feet. I'm down behind a hill, and there's a creek. I'm over 100 feet below average terrain here, even in the neighborhood. You just go a quarter mile up the road here, and you gain 100 feet elevation. So I never really felt it was worth the investment of a tower here, and I've always wanted to put something up out at the farm. Well, the farm is ham towers are permitted up to 200 feet. Don't require any zoning. You just have to apply for a building permit, and you can erect a tower up to 200 feet out where our farm is here. So I always envisioned, now I don't have electricity out there, so I'm going to have to come up with a setup that will run on battery. This thing draws very little power. The other advantage of Linux is it's just so much easier to maintain remotely. You're not constantly being bombarded with updates and downloads. You can turn all of that off. You can freeze your image so that the software doesn't change on you unless you want it to change. And it makes it a much more stable platform when you're not located at the site. And as I mentioned before, there are very inexpensive single board computers running Windows that are starting to become available, and I believe there are versions of Windows that will run on ARM processors. So this does not run on an Intel platform. It uses an ARM platform, and that's how they get the low power consumption. So this is the model Raspberry Pi I have, and what I'm going to do is I'm going to take my SDR Play. I'm unplugging the USB from my laptop, and I'm going to connect it to the Raspberry Pi, which is just sitting here. It's out of view of the camera, but let me connect this to the Raspberry Pi, and I'll show you how this all works. Okay, so we're plugged into the Raspberry Pi, and I'm going to get out of here, and I'm going to bring over Windows PowerShell on my laptop here, and I'm just going to log in to the Raspberry Pi. So I'm connecting to it remotely over my LAN.
I think I see my IP address in there.
Yeah, that's because I was connected. Oh, that's you connecting to me. Yep.
Yeah.
Okay. Okay, so now I'm logged in. Now I'm just going to change directory to the directory with the software in it. No, sorry, it's all lowercase here. So I'm in the right directory. Now I'm just going to launch the server software. So, oh, didn't do that right. I got to put in, okay. And this is just a command to start the SDR Connect software. Okay, and now the software has come up with some default settings. And now that the server is up and running, I'm going to connect to it locally. Couple of things here first. First off, the whole time we've been chatting, I've had an instance of SDR Connect connected to Brent's SDR play. So he's running an RSP1A, and this is the radio running in his shack, and this is what the 40-meter band looks like, the activity on the 40-meter band looks like right now. And I found it very interesting connecting to his and then comparing it to what I can receive on mine. So I'm gonna launch another instance of SDR Connect. I got to get to my desktop to do that. Okay, so here's another instance of SDR Connect. Okay, and I'm going to go ahead and connect to my RSPDX just to make sure I don't overload the bandwidth. I'm going to connect to it audio mode. The IQ mode takes a huge amount of bandwidth because it's sending the raw samples over the network, which is very bandwidth intensive. This just sends the demodulated data, the screen display information and the demodulated audio. So let's go ahead and start this one up. Okay, I'm going to change bands to 40 meters. I got to change my antenna, I believe, to my 40-meter antenna. Okay. Make this a little bit bigger. Let's see. No. Okay.
Crew has arrived. 732 all and 93. Have you seen Roy?
I know, it's a shame. When I took my exam way back in 55 or 54, I don't remember. But I had to go do a written exam and talk.
Okay, so I'm going to turn the volume down there a little bit. And then I'm going to bring up the other instance of SDR Connect, which I believe is this one. And I'm going to try to tune to the same frequency.
They're making the transition from CB to ham really easy.
Yeah, well, they're trying to get as many people in because they thought that.
You can even hear the echo, but I'm on the same frequency now on both radios, the one here in Cincinnati, Ohio, and the one here in Brent's Shack. So this one is the one in Brent's Shack. I have it muted at the moment. Let me mute this one, and I'll unmute this one. Oh.
Well, I'm sure they do. I mean, all that is corrupt. I understand that.
So there's.
Whatever happened to the manufacturer in Tennessee? The name slipped my mind from there. They made a lot of good radios.
Syntec, Bill?
Yeah, Syntec.
Okay, I went ahead and muted both of those. But I mean, it's very, you know, like I said, with access to the remote radios, the radio in my shack operates identically to the one in Brent's shack, and I can tune into the same frequency. And you know, earlier this afternoon, The strong local signals I was hearing, you couldn't hear at all up north and near Fredericton, and vice versa. But now here at nighttime, I can hear, many of the same signals are clearly copyable. The other thing I was listening to around 4 p.m. local on Brent's shack, I was hearing the UK come in very, very strongly. And here in the Midwest, here in Cincinnati, Ohio, it was, the signals were just barely above the noise level from the UK. So it was very interesting to be able to tell the difference in propagation and how everything's coming in. So I don't know if we want to do anything else as a demo. I mean, I think we can wrap this up, or if you want to, if one of the guys up north wants to connect to the radio, I can disconnect and they can connect to my radio.
Well, in fact, we might have questions. I'm going to jump in with one question, and that is only one person at a time can connect?
No, it will let 8 people at a, you can have up to, well, actually you can set it. Default is 8. It will allow eight clients to connect. Now, the first client that connects controls the local oscillator frequency. Okay. So what that means is that the first client to connect, he's the only one that can change the sampling rate. He's the only one that can change the bands. So let me zoom out to 100% here. And then I want to do 40-meter band. Okay. So if I have the 40-meter band selected as the first one to connect, the next user that connects to the radio will automatically be tuned to the same band segment. They can listen to any of the signals in the band. They can tune to any one they want, but they'll be using the same band segment that the first user selects. So that's the only limitation when you have multiple users that connect.
Yeah, if you want to try, Malcolm. Sure.
If I bring PowerShell back up here, I should be able to see if...
I had also connected, Ted. Yeah, that's Malcolm.
Okay.
I'll edit out your IP address, Malcolm.
Appreciate it.
Is there so we've heard about these SDRs through talking with other questions here. I've got some, but I'll pass it over to anybody who's got questions in the group.
I have a question.
John.
First of all, who said a person can't be in 2 places at once? So welcome to New Brunswick, Ted. And we're in Cincinnati at the same time. But the SDR Play hardware, is that got a separate power supply, or is it being powered by the Raspberry Pi's USB?
It's being powered by the USB of the Raspberry Pi. It does not have its own power supply. And my Raspberry Pi power supply cost $8.99. It wasn't very expensive.
Are there other questions?
This is Walter. So
Walter, yeah.
I am wondering if, Ted, if you're familiar with the web SDR at the Department of Electrical Engineering at Enschede in the Netherlands.
I'm not familiar with that particular web SDR. I've used web SDRs before.
Okay, yeah, I was just and I've seen a few others, but I was just wondering if the software is essentially the same, because it appeared that the web SDR had a little more capability. It would host multiple users that could independently control bandwidth, center frequency, etc. Yeah. But I guess this one is a little scaled down compared to something that would be running at the university.
Well, what you can do is you can cover up to a 10 megahertz slice of spectrum. So if I set this up to cover a full 10 megahertz of spectrum, any of the connected users could tune anywhere within that 10 megahertz bandwidth. So you could, you could easily cover 80 meters. You should be able to cover then, not well. You'll run a little short of getting all the way up to 20 meters, but you can cover 80 meters and 40 meters at the same time, 40 meters, 20 meters at the same time, and you could cover 20 meters and 15 meters at the same time in one segment like that. The other thing is that's where you're going to start to see the difference between a direct conversion type SDR and a direct sampling SDR. So I mentioned Kiwi SDR at the beginning. That's a direct sampling SDR, and a lot of the web SDRs use the Kiwi SDR because it does have that higher, that faster analog to digital converter. It's direct sampling, and it can cover, it can down convert the entire HF band.
Yeah. Well, I'm just curious. Now, what part of Cincinnati do you live in?
I was going to say one difficulty you have if you try to cover the whole HF band at one time is you have to have an antenna that functions across the whole HF band at one time. So, you either have to have a multi-ham band antenna like an end-fed half wave that's got a good match, or a lot of people use magnetic loops on the SDRs because they're broadband. And make reasonable receive antennas, log periodics. You have to solve that problem, I guess.
Yeah. I was curious as to what part of Cincinnati you lived in.
Oh, I'm on the east side in an area called Anderson Township. It's on the kind of on the eastern edge of the Circle Freeway.
Yeah.
Around the city.
Okay, because I worked in Mason for a little bit, and I used the rails to trails conversion. It goes from Cincy up through up close to Xenia and Dayton.
Yeah, I rode that trail up to Xenia and back in a day before.
Yeah.
That's a pretty good haul. It's 100 miles up there and back. So it's a pretty good ride. I was a little younger at the time, but it was fun riding. It's great. Any other questions?
I've got one, Ted. Oh, Jerry?
Ted, could you tune the CW band and see if you can copy my signal down there?
Sure. I bet if I use Brent's receiver, I can copy you really well on the CW band. But got a frequency in mind? We'll compare them. We'll see what you're like on each receiver.
7020.
7020. Okay. Let me get into CW mode. So we're going to change to CW. I'm going to use a 500 hertz filter. That should be fine. Let me zoom in a little bit. Okay. This is Brent's receiver. So let's see how good you sound at Brent's QTH.
Okay.
Okay. You were, oh, I had it, did I have it muted?
Yeah.
Yeah, I had it muted. Go ahead and...
You mute, Jerry.
Go ahead and do it again, Jerry.
Yeah, okay.
You're muted, Jerry. I guess you're having a hard... The delay in the audio is messing you up, isn't it?
Yeah, it is.
Yeah, that delayed side tone makes it... Now, let's see what you sound like on the Cincinnati receiver, which... Okay, I got it muted. Unmute this one. Okay. Let me go down to 7020. And then let me put it in CW mode. All right, I gotta get, there we go. CW, 500 hertz, and
Now, do you want my mic off or on?
it works a little bit better if your mic is off. Why don't you try sending your call again and see how you are in Cincinnati. We'll see how you look in Cincinnati.
Okay, I'll have to turn my volume down.
Yeah, I'm gonna go ahead and mute. But I mean, your signals were actually was pretty similar in signal strength.
Yeah.
A lot of fading, a lot more QSB on the local, Cincinnati receiver versus the Fredericton receiver.
Yeah.
Okay, yeah. It's, when the mute is on, there's a delay, and it's really screwed.
Oh yeah, the delay makes it very hard to send CW without an accurate side tone.
Yeah.
Really hard. So, well, that pretty much wraps up my presentation. I think I've covered all the topics I intended to discuss tonight.
Yeah. I also wonder if there's a list that one can post about SDR connects that are on the web. I mean, we just heard about these ones because we were talking and
Yeah.
we shared IP addresses.
Yes, I don't know if there's a list. This software has only been on the market since,
Right.
when was it released? Late December?
Right.
And the second release came out, I thought, in January, and it is still beta software. It's missing a lot of basic features at the moment. So for example, it doesn't have programmable memories, which, you kind of configure, that's a very basic feature. It doesn't have a noise blanker in it. So if you want all the features, you have to use their traditional Windows software, which does not, it's not client server based, and it only runs on the local host. Can't use it for remote operation. Yeah. But at the rate they've been throwing the features out there, I am hopeful that in a year, they'll have all the basic features you'd expect. Like you would certainly expect to have programmable memories. You would expect to have a noise blanker. Things of that nature.
It was, although it's beta, I decided I would try and set it up last night, and I set up the server last night from scratch. So it worked pretty well.
Yeah, I haven't found very many bugs in it, and I've found that what they have implemented works as advertised. So
yeah, okay, thank you.
And the nice thing about it is that I can run it on the Raspberry Pi, I can run it on Windows, I can run it on and the software works identically. I mean, the graphics are exactly the same. Everything about it is identical.
Yeah, I had a Raspberry Pi 5 for the server, and I'm connected by a PC and connected by a Mac. Yeah, that's great. All right, are there any last questions?
So these slides will be put up at some point, Brent, or the video, I guess?
Yeah, I'll try and edit it as fast as I can. Takes about a month or so.
So these slides are in Google, what do they call it? Google Slides? I can't remember what they call it. I can just share the file with you and you'll have direct access to it with a link.
Thank you very much. I will stop recording.